Now we're going to move from making observations to making the data useful. Our next speaker is Professor Ryan Abernathey, who leads the Ocean Transport Group at Columbia University. Let us please play Ryan's video.
Thanks for the opportunity to speak at Smart Oceans. My lightning talk is about my vision for how we can make ocean data more useful using open cloud architecture. A little bit about myself. My name is Ryan Abernathey. I'm a physical oceanographer at Columbia University. I work with satellite data and large-scale ocean simulations. And this work has also led me to start contributing to various open source software projects. This talk is going to describe what I see as a central problem facing oceanography, which is that ocean data is huge and complex. And I'm going to propose a solution that we call open cloud architecture for data proximate computing and invite you to join in collaboration on this project. So this beautiful animation from NASA really drives home how intricate and complex Earth system data are. We're seeing half a dozen different fields from satellites and from simulations that show different components of the Earth system. And the richness of this data is a blessing for science because there's so many fascinating processes contained in it. But it's also a huge challenge for our infrastructure and for our computing. This figure from NASA really drives that home, showing that they're planning to add 200 petabytes of data to their archives over the next 5 years. If you're like me, you were raised with the download model, where the way you work with data is to first download it to your local computer and then analyze it. And this way of working, I don't think is going to take us into the future of oceanography. For one thing, it really can't scale up to handle those petabytes of data. And two, it poses a lot of barriers to reproducibility and shareability and transparency in our scientific data analysis. So the one alternative, is to use what we call open cloud architecture. Now, by cloud, I just mean any computing resource that combines publicly accessible data with publicly accessible computing. We have amazing tools for interactive scientific computing in programming languages like Python, Julia, and R. And the Jupyter project allows us to interactively interact with our computing system in really novel and creative ways. We also have great parallel computing frameworks like Spark or Dask that allow us to scale our analysis up using hundreds of computers. And we also have fantastic analysis-ready data formats that are optimized for cloud storage, such as Parquet, Cog, Zar, and TileDB. Now, all of the things you see on my screen right now are completely open source and can be deployed in any cloud-like environment, including all of the commercial cloud providers or federally sponsored computing resources like Jetstream or the Cheyenne supercomputer. So the Pangeo project is a community platform for big data geoscience that tries to implement this vision through a concrete set of tools. We started as a grassroots collaboration between scientists and software developers. We got some support from the NSF EarthCube program, and we've grown to include dozens of international partners from academia and industry. Pangeo practices open source community development. I'm not going to get into the details of Pangeo technology, but I'll just say that it's all driven by scientific users and real use cases, and we contribute very broadly across the open source software ecosystem and deploy these tools in a wide range of different environments. And we've been doing this iteratively for several years, and I think we've made really big progress in changing the way we interact with Earth system data. So rather than going through a bunch of technical details and showing a lot of plots, I think a few tweets that I pulled off Twitter really get the point across of the impact our project might be able to have. Here's one from a grad student at University of Washington who participated in one of our hackathons, and he talks about how Pangeo has changed the way he thinks about and hopefully does climate model analysis in the future. So if you're interested in these problems and you'd like to get more involved and collaborate around open cloud architecture, on my screen you can see a bunch of links where you can learn more about the Pangeo project. Thanks a lot for your time.
Very exciting work. Thank you very much to Ryan. A reminder to the audience to ask questions and upvote them to our speakers on Slido, as we will be asking the most upvoted questions at the end of the panel live.